welcome back to Josh Does Math. In this video, we're going to be finding the derivative of a function, and that function involves a root. And we're not going to be using the power rule or anything like that. Instead, we're going to be using the definition of a derivative. So that's given by this equation right here. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're going to be using this equation right here. Okay, so let's just start filling it in with stuff we're given. So if I were to look for f of x plus h, I just write out f of x, so that's root of 2 times, and in for x, I'm putting x plus h. There we go. Now for f of x, I just write out f of x. Okay, and that's all over h, so I write out h. So now our goal is to evaluate this limit. Well, why don't we try direct substitution? Let's see what happens. If I try direct substitution, I end up getting 0 over 0, which is an indeterminate form. It doesn't tell me anything about what this limit is equal to, so that's not good. So we got to manipulate this algebraically so that we get out of that indeterminate form. Okay, so how could we manipulate this? There's no power of 2 or distributing in the numerator and denominator to simplify stuff. There's no common denominators that I should find because we just have everything over a common denominator already. But we have roots, and whenever you see roots like this, especially like one root being subtracted or added to another root, and you want to simplify it, it's a good indication that you should be using the conjugate of the root. So I'm going to write out this next step, and I'm going to multiply by the conjugate on the top and bottom. It doesn't change anything because I'm multiplying by it on the top and bottom, but it can help us simplify some stuff. So in the numerator here, we have root of 2. I'm going to distribute that to 2x plus 2h minus root of 2x. In the denominator, we have h. So now I'm going to multiply on the top and bottom by the conjugate of this mess involving the roots. So the conjugate is just the same thing, except for one little change. And that change is that you change the sign between the two conjugates. And this might look like we just made things a lot worse, but it's going to be better in the long run. So limit as h goes to 0. Whenever we multiply something by its conjugate, this simplifies things really well for roots. Because imagine if we were to do FOIL with this, multiply by this, and then this, multiply by this, and whenever you do FOIL like this, you end up getting just the difference of squares, right? A plus b times a minus b is going to equal a squared minus b squared. Well, just imagine that this is a right here, and that this is b. Whenever we do this FOIL over here, we end up getting an answer that involves only the squares of a and b. And the fact that a and b themselves are roots means that whenever we do the squares of a and b, it's going to simplify them a lot because it just completely removes the roots. So this becomes 2x plus 2h, so that's a squared, and it's going to be minus b squared. B squared is just 2x, and that's the entire numerator. Well, how about the denominator? The denominator certainly looks worse, but maybe it's not as bad as it seems. Well, in the numerator right here, you can see that we've got 2 terms here that cancel, negative 2x and 2x. We're left with just 2h. And, oh look, there's an h in the numerator and an h factor in the denominator. Well, let's cancel them. And now we're just left with this, and that's it. Okay, let's see what happens if we plug in 0 for h and we try to do the limit the way we originally tried to. We're going to get 2 over root of 2x plus 0 plus root of 2x, which is just equal to 2 over 2 times the root of 2x, which is just equal to 1 over the root of 2x. And that's it. And the fact that we didn't get some indeterminate form, we got an actual answer, is good, because this is the derivative of f with respect to x. And we had to use conjugates because we had an indeterminate form, but this is the final answer down here. Thanks for watching.